Hello and welcome to Martin Maths. We're continuing our Desmos series using the wonderful website Desmos to visualize some graphs and help us solve some maths problems. So we've seen in our other video about how a quadratic can be transformed and how a quadratic can intercept with a straight line. But Desmos is great at looking at other graphs as well. So if I typed in y equal to x squared, I would get this red graph here. And then if I type in y equal to x cubed, you can see the features and properties of a cubic graph now. So I'll get rid of that quadratic graph and we can see how the cubic has that point of inflection. And obviously we could look at similar transformations. What would happen if that has a constant term? What would happen to that if it has a quadratic term in it? And that's where you get a bit more of that hump in that curve. So there's a local maximum and maybe a point of inflection. And then you could have a linear point in there as well. We could increase the powers there. We could look at a quartic. If I get rid of the cubic one there. And then you could see if you were to introduce slider terms in there, coefficients of each of those, powers of x, then you could also just play around with the different effects that those coefficients have on the quartic there. So that's quadratic, cubic, and quartic. Another interesting one is the reciprocal graph, just 1 over x. As you can see, it has asymptotes. And what's useful is that we can now write in what those equations of those lines of asymptotes are. Say the axes, y equal to 0, and x equal to 0. But obviously any transformation to that, maybe if I had a constant term there, would shift that up. And so the line that is the equation of the asymptote would also move. In this case, it's y equal to 5. So that's looking at the reciprocal graph. Another interesting graph to look at is the exponential graph, which is y equal to a to the x. And we can change what that a is if I have a slider there for a. Remembering that anything to the 0 is going to give us the point 1. So all of our exponential graphs should go through 0, 1 there. If I'm going to change that, instead of a slider, just have, say, 3. They're all going to go through the point 0, 1. One final graph to look at would be the circles. Now, x squared plus y squared is equal to a, and I could play around with how big I want that a to be. So maybe the radius is 3, or the radius is 4, and you can have that playing if you like. Similarly, as we said before, if we change that to an inequality, then you'd get the region shaded in, or an inequality the other way, and you could play around with that graph there. Obviously when it's less than 0 there won't be a circle there. So there we go. One thing that is interesting to look at, if I get rid of the circle and just look at that exponential graph, again we can look at that axis of the equation of the asymptote, which in this case would be y equal to 0. And if you wanted to look back at, say, your quadratic graph, if I get rid of all those, so y equal to x squared, and someone says, what is the range of that? Well, an inequality would be a nice way of representing that. So if we do y less than 0, then you can see that the range is y greater than 0 because everything else is shaded out. So Desmos allows us a nice feature there. Okay, one last thing I wanted to look at was using the graph to maybe solve some problems. So if we took a complicated one, so y equal to 21 plus 79 over x, so it's a transformed reciprocal graph. We can see that our equation of our asymptote is y equal to 21, and we might be asked to find out what would happen when x is 10, and we could just plug that into there using it like a calculator, and we have that 28.9 as the answer for y. And similarly we could use that graph to solve for other things. When would that, if this was time, when would that reach 30? And we could see there it would be at 8.76 or so on. Okay, so there's just some examples of how to use Desmos to use it as problem solving, visualizing, and graphing. Thanks for watching. Don't forget to like, subscribe, and share, and continue watching this Desmos series.